Okay, so today's, I guess, lesson is going to, once again, review all the different steps that we have taken to sketch properly. And I'm going to show you today something new. Instead of using logic or guessing, quote unquote, by looking at the equation, we can use some math to test the limit. So today, big flow explosion, we are going to learn how to test the limit, quote unquote, by using, so that we know what the behavior is near the vertical asymptote. We know what the behavior is as we go positive infinity and negative infinity. Where are we heading towards and what's happening here? Does that sort of make sense? I don't want to dance more than that in front of you, so let's get to it. From there, we are going to use this to try to do this all together. So let me get a show of hands. You didn't do this. I think I did this on my own, right? Yeah. Okay. So this is the answer, but we'll go through it. How many people got a chance to do the final example yesterday? Oh, right on. Who here was awfully ashamed that they didn't do the homework for me?
So ashamed. Oh, I'm so sorry.
Okay. How about I just erase the answers on the bottom and just go through it? Okay. And I will do everything, but while we do everything, I want you to save some space when we get to the asymptote portion, because you will see me doing something slightly different than yesterday. Okay, to confirm mathematically what these vertical asymptotes are. So far, so good. And I'm gonna throw on to that how we can do the exact same thing for more complicated functions. That's our goal today. My goal is to get through at least the quadratic reciprocals, so that over the homework, over the weekend, the long weekend, I mean, you should take your break Thursday, absolutely. But tomorrow being a PA day, I hope you will designate some time to do some practice. If you didn't know already, there is going to be a quiz on sketching, all the stuff, the DISAI stuff, the DISAI acronym, Thursday. That's your goal, to be able to sketch so comfortably that no question I give you is going to be hard. Let's do an objective. Today's objective is to be able to do DISAIMIC without the mic, DISAI, yeah, DISAI, anywhere between 5 to 10 minutes. Any question, domain, intercepts, symmetry, you skip asymptote and interval notation or interval sign chart, 5 to 10 minutes. What?
Yay.
DI. Okay, anyways, enough of that. Let's do it. Okay. Let's erase all this very quickly. My function is 4 over 5 minus x. You should, oh my gosh, why my life? I need a better tablet thing. This little art stylus thingy. Okay, starting with domain. You got it already?
X equals a real number, x cannot be 5.
Correct. So if you're wondering how we can get the domain quickly, you're basically checking when will this equal a 0? The denominator, when will it equal 0? Well, do your algebra. That becomes a -5, which means x must be 5. If I want the denominator to be a 0, x would be a 5. Therefore, my restriction is x cannot be a 5. Good. Intercepts. I'm going to do the easy one first. I'm going to set x equals 0 so that I can find my y-intercept. 4 over 5 minus 0, of course, is just 4 over 5. Therefore, my x-intercept, sorry, my y-intercept is 0, 4, 5. Secondly, if I want the x-intercept, my y value must be a 0. So I'm going to set the entire function, aka the y value, into a 0, and I want to find what value of x makes this true. Well, that numerator will never be 0. Therefore, x-intercept does not exist. Question? I'm just using logic here. Any fraction, no matter what the denominator is, 1,000, 1 over 9999999, it doesn't matter. It's really close to 0, but is it 0? No. So by logic, if the denominator does not have an x, you know that that can never be a 0. Sure, by algebra, you're right. If I multiply both sides by 5 minus x, 0 times 5 minus x equals 4. 0 equals 4? That makes no sense. It's impossible. Therefore, it does not exist. No value of x will make this true. Symmetry, skip. Asymptote. So here it is. This is the part I need everyone to pay attention to. First off, we already know what the vertical asymptote is. What is it? Look at the domain, the 1x value. Yes. So you look at the domain, you already know right away the vertical asymptote is x equals 5. So it's going to look something like this. But here's the thing. Is it going to be like that? Or is it going to be like this? Or is it going to be like that? And like this? I don't know. We're going to test the limit. Ready? Here is a new notation. What we're going to do is check the behavior when x is equal to 5.00000000001. I want to know where I'm going to be if I'm infinitely close to 5 on the right side. Does that make sense? I want to know if it's going to be up here or down here. I also want to check what the behavior is if x equals 4.9999999999999999999. So infinitely close to 5, but on the left side, right? Here's a problem. As a mathematician, do I really want to write that? And let me show you what the notation looks like. And I'll ask you the question again. If you want to test the limit, we write this. The limit of the function 4 over 5 minus x. Is this a negative? No, just positive. Okay, 4 over 5 minus x as x approaches 5.000000000000001. Does that look like that will pass for mathematicians? No. Why? Main reason? Mathematicians are lazy.
Would it be 5.0?
Oh, that's not a bad idea. 5.0 line over it and then 1.
What's it called?
Just repeating, right? I don't know. But instead of that, we actually created something new. I'll show you how lazy mathematicians are. We can't even be bothered to write limit. We write lim. Okay? The limit as x approaches the 5, but from the positive side. Slightly above 5. Yes. X arrow, so x approaches, x goes to 5 on the positive side. What does that equal? You test it. In your head, you can do it, or you can write it down. I do it in my head, but for you, I will write this for you. 5 minus 5. Slightly bigger than 5. Put as many zeros as your calculator can handle. What will you get? Oh, come on. 5 minus the same number, but a little bit more. 0.0000000000000. Wow, that voice is going to be recorded. I just realized.
I'm taking a number that
Anyways, let's keep going. 4 divided by an infinitely small number.
let me try this. Let me try
An
this.
infinitely large number. Yes. All right. It's negative. So it's going to be an infinitely small number, infinitely negative value. So what does that mean? On the right side of my vertical asymptote, it's going to be low. It's going to be right here. It's going to be down here.
That's like it.
Okay, so let me erase all this. We don't need all this right now. You're going to get to it later. Okay. Let's test the next one. What about if x was approaching 5, but from the negative side? So in other words, left of the vertical asymptote. This time I like to do it a little bit in my head. 4 over 5 minus 4.99999. This is not -5, please. This is not -5. It's a number slightly under 5. So 4.99999999999. So it will be 4 over a positive 0.000001, which means it's going to be a positive infinity. As a graph, what does that mean? It means I have a vertical asymptote at 5. And if I am on the right side of the asymptote, it is negative. So it's going to be somewhere here. And if I'm to the left of 5, it's going to be a positive infinity. So it's going to be somewhere there. So it's a clue. All the other things gave you good clues, but this is another clue that will help you graph accurately. So now that I did this, what do you think I have to test now? How do I test this and how do I test that? What x value do you think I'm going to push to the limit? X equals? Yes. Think of the biggest number you can think of. I'm going to push it to the limit and check what the behavior is. You will see that it will give you an asymptote of 0. But this is what it looks like. You ready? Horizontal asymptote. Horizontal asymptote is basically test x goes to positive infinity and x goes to negative infinity. That's what a horizontal asymptote actually is. So here we go. Let's do it. What is the limit as x approaches positive infinity, so the right side of the graph, of 4 over 5 minus x? Speaking of that line, I think it's like a more common technique in America. I think students like in middle school or high school are taught, if you're taking notes, especially jot to point form, they get you to fold your piece of paper and make a crease, and your notes are not allowed to go past that half mark. It may not be a bad strategy when you're doing questions like this. Okay. So what do you think? Can I do this in my head? I would like to. Limit as x approaches infinity. What is the denominator? 5 minus infinity. Or negative infinity, add a 5 to it. What's my answer? Negative infinity plus 5, that's like a drop in the bucket, right? There is no change to the denominator. So what is the final answer when you have 4 divided by a gigantic number. It approaches 4 divided by a gazillion. Not a negative gazillion, but the opposite of it. Negative of 0. 4 divided by a huge number is a 0. It's so small. Try it. Take your calculator, do 4 divided by 99999, as many 9s as your calculator can handle, and tell me what you get. Right? It should approach a 0. But is it a 0? No. Not quite. Almost a 0. Is it above a 0 or below a 0? It's 4 divided by a negative value. So it's going to be, it would be a negative 0, but that looks really funny because a 0 is not a negative. So what we write is, just like before, it's 0, but slightly under. Limit as x approaches a negative infinity of 4 over 5 minus x. For this one, I might have to show you some work so that people can don't have to work too hard for this. 4 over 5 minus an infinity is the same as saying plus whatever that number is. In other words, that's still 4 over infinity. What does that approach? Same situation. It approaches a 0, but on the positive end. Seeing these two, you can affirm that horizontal asymptotes do exist when y approaches 0. The graph will approach 0 when you go left and right. Yes. There's no, I don't think there's a number. I don't, if there is, and I don't remember it. It's just a symbol. So I know that not in the middle per se, but as we go left and right of the graph, if I move to the right, it approaches 0, but above it or below? Below. So it's going to be somewhere here. If I'm moving to the left, it approaches 0, but from above or from below? It's a plus. So from above, it's going to be above that dotted line. So already, even if I don't give you the y-intercept, do you see where I have to go? The left arrow needs to connect to this arrow before teleporting down here and connecting to that arrow. Behaviors. How does it behave near this dotted line? How does it behave near that dotted line? So that is, this part is, I'm going to say new. Okay, that's the new part. The intervals is something you've done before. I don't have much space. X-intercepts, no x-intercepts. Vertical asymptotes, 1 vertical asymptote. The 4 is a positive 4 no matter where I go, and 5 minus x, I must watch out. Otherwise, this is my function. So left of 5, let's do negative 1 million. 4 is a positive, this becomes a positive. So the function is above the x-axis. Over 5, let's do a positive 1 million. 4 is a plus, 5 minus a million, that's a negative. There. What does this graph tell me? If I am to the left of this asymptote, okay, I am going to be on the positive side of the x-axis. If I am to the right of the asymptote, I'm going to be under the x-axis. And that agrees with my arrows. 1 and 2.
What's the point of using asymptotes if we're like, or using intervals if we can use the limit to find asymptotes? It's like check.
When it's another confirmation, but when the graph gets more complicated, it does help quite a bit. So right now it's simple and it seems to overlap, but you will see how they give you different information later on. No, sometimes a horizontal asymptote will not be a 0. So sometimes it'll be here, but it might be underneath, but it have to be over the x-axis and blah, blah, blah. Not yet. You will see as we get more complicated again, these pieces will show you all the information you need to know. Right now, they're overlapping. So it's like an extra confirmation, but later it will show different. Okay, so I put all these pieces in. I know it's going to be top left and bottom right. The y-intercept is 0, 4/5. So somewhere here. Putting all this information together, there's your graph. It might seem excessive because you may feel like you're doing the same stuff in different ways. And yes, that's true. So now I am sort of ready to show you some more complicated versions. Okay. Let me save this because I'm going to put it up online for everyone. Yes.
So for this question, is there a way to tell
No. This part, this area of how steep or how stretched the curve is, purely eyeballing. Yes, absolutely. One thing I want to mention, which is sort of interesting, it's like, Mr. Kim, how does this relate to our transformations, AKDC? Right? Take a look. If this function 4/5 minus x, oh my goodness, what is going on? 4/5 minus x was rewritten in AKDC form, we would have 4/-x minus 5. There is a horizontal reflection, there is a vertical stretch of 4, and we move to the right by 5. You know, reciprocal used to be here, right? So there's a horizontal reflection, it was stretched by 4, and we moved to the right by 5. No, I'm just saying that it still works with what you learned in grade 11, but you will see more complicated versions where AKDC is just too hard. Case in point, please take a look at today's sheets 3.2. So I won't be able to go through all of this with you. I think it's more important and also easier to understand if I just do the examples using DISAI. I just want you to know a couple of things, which I was going to point out anyways. No matter what, when it comes to a reciprocal, this is still true. The zeros of a polynomial function will be the vertical asymptotes of its reciprocal. So here, what are the zeros? What makes this function equal a 0? X equals 0. No. 5. Yes. And that means, what are the vertical asymptotes of this? 5. In the same way, for a polynomial or a quadratic, domain is just whatever. But if you have a reciprocal, because there's a denominator, the vertical asymptotes immediately translate into vertical asymptotes. Sorry, the vertical asymptote immediately translates into restrictions. And all of this on the bottom, y-intercept, horizontal, and that stuff we will perform on our own. What I want to also mention is, right, noticing this, the intervals of a parabola and the intervals of a reciprocal that are positive and negative are equal to each other, just like before. But if you were to test, is it increasing or decreasing? These two will flip just like before. Now, instead of writing stuff that will make it more confusing for you, I'm going to perform it, I'm going to graph it, and I think that'll be better for you. Oh, yay. My yet born third child fetus is looking healthy. Yay. But it was a scare, just to give everyone some context, it was a bit of a scare because my wife was pregnant with our third before, but we lost it. And that was an eye-opening experience. Like, I was very biased and prejudiced, and I was like, oh, people can't have babies because, you know, they're ruining their bodies and putting bad things in their bodies and taking too many like medicines and drugs and whatever it is. And then that happened to my wife, so I was very humbled. It's a good learning experience. At the same time, I was heartbroken. So this is past first trimester and the heartbeat's still there, so yay. Let's keep going. That was a good distraction. Please note, when you turn the page and get to the first example, you will see that the printer did not add a 36. Would you add that into your sheet? Oh, you do?
I don't got nothing.
No, I accidentally did not double-side it, so I killed some trees. But if you go to example 1, second page, the front of the second page, you will see that it says x squared minus 12x, but no plus 36. You add the 36, please. Yeah, I killed some trees, so I feel that.
So what, we're gonna have to factor it?
Yes. So right now it's in polynomial, it's in standard or simplified form. This doesn't help us. I'm gonna factor it for you just to save myself some time and I don't have to wait. This is going to be negative 4 over x minus 6 bracket x minus 6. You can also write it as, why are you doing this to me? Negative 4 over x minus 6 squared. Both are okay. So some interesting stuff happens. This is not as difficult as some of the other ones I might see, let's say example 2, but it's a good place to start. Let's do domain. I'm going to challenge you. Can you complete all of this the same way we did before with all the same steps in 5 minutes? Let's see how far we get. I'm going to pause the video, see how far you get in 5 minutes. All right, so we're on the right track, I think. Domain, right off the bat, I am going to say it can be anything as long as the denominator is not a 0, therefore x cannot be 6. And I'm going to remind myself this also doubles up as a vertical asymptote. Intercept, yes, question.
So I wrote down square root of 6. How come it's not square root?
X over x minus 2 squared has to equal 0, right? When you square root, it's still 0.
Oh.
So by algebra. Good question. F of 0, that means negative 4 over 0 minus 6. So negative 6 squared, that's a positive 36. So therefore, my y-intercept is 0, negative 1 over 9. 4 over 36. I will test for x-intercepts. The y value is a 0. So what value of x will turn this function into a 0? None. Because the numerator here will never be 0. It'll never equal 0. Symmetry, I'm going to skip. Let's do asymptotes. Here we go. Question?
Why is it negative?
Pardon? Which part? This part. Well, negative 4, 0 minus 6 squared. Okay. As long as we got it. Asymptote. My vertical asymptote is already established. It's a 6. Let's test it. The limit, as x approaches 6 from the positive side, we've got negative 4. Can I do this in my head? 6.000001 minus 6 is going to be an infinitely small number squared. Some of you will start creating a shortcut for yourself because even this is annoying. When I was in school, what I did was I wrote this. It's basically a 0, but slightly above it. If you don't like it, don't worry about it. Welcome. So this equals -4 minus an infinitely small number. So this is going to be a negative infinity. Let's test the next one. Do I have space? Sure, I have space. Limit. X approaches 6 from the negative side, so 5.99999 of -4 over x minus 6 squared. So this is going to be the same quantity, but negative. So you could write this as -4 over -0.000000001. Or if you are like me, you can write this as -4 over 0, but from the negative side, just to tell myself that it's negative. I just don't like writing stuff like that. It takes up so much space on my paper, blah, 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 messy writing, blah, blah, blah. Okay, just want to let you know. And if I do that, I know that the final answer is going to be -4 over a really small number. That's going to be negative infinity. Would it help you to remember if I wrote something like this? I don't know if this is still a meme, but like, what if I wrote just small like that? Does that make sense? Will you remember? You know what I'm saying? Right? As long as you do whatever you need to remember, right? Create shortcuts so that you don't have to deal with that. Like if you want, just replace -0.001, right? And know that it's a conceptual idea, a tiny, tiny value. Just write negative small. You can do that. Do whatever it takes to understand what I'm trying to say. Make sense? Yeah, does that make sense? Okay, so let's continue. We've established and confirmed the behavior at vertical asymptotes. So case in point, I think Ryan or somebody asked, like, if you have one as a negative infinity, does that mean the other one's a positive infinity? Obviously, in this case, you see that it's not always, so you must test everything. Let's continue. Horizontal asymptote. I ran out of space here, so I am going to continue writing up here. Horizontal asymptote. I do not know what it is, but I am going to test x goes to positive infinity and x goes to negative infinity. Let's test both. So the limit as x goes to positive infinity is here, I'm gonna do this again. I like that I like that dividing line. I think it really helps. Wow, this is the extent of my like fish memory right now. This was the class I told you about folding from the States, right? Yeah. I just told you like 10 minutes ago, right? See, I forgot I did that. I thought I was telling you for the first time, and I'm like, no, it sounds, I feel like deja vu. Fish memory. You know, like, you know where the word bird brain comes from? You know why you call it, like, there was an insult where you call a stupid person a bird brain? You don't know.
This guy, Mr. King.
Anyone know?
It's not me.
It's not only that. Birds are so quick to forget, right? That like if there's a fence, let's pretend there's an experiment where they put a fence. There's a tiny hole that a bird can get through on the other side, like a chicken, right? And they put them on one side of the fence and food on the other side. The chicken couldn't figure out how to get to the other side and starve to do that, right? But what's interesting and very heartwarming is that when you put a chicken on one side and put their chicks on the other side, they find it. Pretty heartwarming, right? Because it's their child, like they don't give up, whereas for food, they're just like, oh, I'll just die, right? What's interesting about fish is that fish, when a predator comes to eat the fish, they will run, obviously. But within a few seconds, they forget why they're running and they stop.
So fish brain.
Fish made me right now. Okay, so that's interesting. So we've got negative 4 over infinity minus 6. Infinity minus a 6. That's literally removing a drop from the bucket of water, right? That's nothing. So this is still infinity squared, which obviously is still infinity. Negative 4 over infinity, it's basically approaching what number? 0. A 0. But is it a 0? Not equal to 0, almost a 0. You could say, some people can argue that it's a negative 0, but that's not mathematically accurate either. You can't have a positive or a negative 0. So instead, what we say is it's 0, but slightly smaller than it. It's underneath 0. Limit as x approaches negative infinity of negative 4 over x minus 6 squared equals negative 4 over negative infinity minus 6. It's like you're $1 million in debt and you borrow $6 more. It doesn't make a difference. Or you're a gazillionaire and you earn $6 more. It doesn't make a difference. So this is still a negative infinity squared. And negative anything squared obviously is positive. Negative 4 over infinity is about 0, but once again, on the negative side. It's graphic. Oh, intervals, I forgot. Intervals. X-intercepts, none. Vertical asymptote, 6. Parts of the graph that will change the sign. There's a negative 4 and x minus 6 squared. Oh, but hey, this is going to be easy. No matter what x is, what is negative 4 going to be? Negative. Bam, bam. No matter what x is, what is a square going to be? Bam, bam. So we've got, these are all the clues I'm going to add in to my graph. Here we go. All right, let's start from the top. My domain is this, which we'll get to later. My intercepts is 0, negative 1 over 9. So negative 1 over 9, somewhere there. Okay, no x-intercepts, great. My vertical asymptote is a 6. So x equals 6. I might need this area, so x equals 6. Okay, and if I am to the right of 6, it's going to be a negative infinity. So it's going to be somewhere here. If I'm to the left of 6, it's going to be negative infinity. So somewhere here. Horizontal. As I push to the right or my left, I am approaching the value of 0. So my horizontal asymptote is y equals 0. But both sides, no matter what direction I go, they're approaching 0 from the negative direction. So I know that I have to have an asymptote here. I know there is an asymptote here, and it approaches underneath. It approaches underneath. And of course, the interval tells me that left of the 6, I have to be under the x-axis. To the right of 6, I have to be under the x-axis. Put these two parts, put all of this together. Do you visualize in your head? Can you visualize in your head? What does the curve look like? It goes from here, connects to this point, because that's the y-intercept, and goes down because we tested it. And it doesn't teleport to the positive side. There it is. That's it. This is curve sketching. I'm going to ask you, I'm going to challenge you to do a more complicated version. Go through all the motions. And if you can still go through all of these motions, even if I give you harder versions of this, you'll be okay. The next example I want to give you is that I factored it for you so that you can work with the denominator easily. Can you go through this? I'm going to say again, this time I'll give you 6 minutes. See how much of this you can accomplish, including testing the vertical asymptotes. Try it. Okay, for the sake of the video, I am going to repeat myself. As you start calculating, you'll notice that there are 2 vertical asymptotes this time. When you test the behavior left and right of those vertical asymptotes, calculations can get long. I strongly encourage you to develop that conceptual mindset where you can do it in your head so you can save time, as long as you do it accurately. But here we go. Domain. X could be anything, but of course, because of the denominator, X cannot be a -3/2, nor can it be a +2. Intercepts. Let's do the easy one. When X equals 0, this becomes 3 times a -2. This is -1/6. So my y-intercept is 1/(-1/6). Okay. Can I make the entire y value equal a 0? The answer is no.
Is there every situation where it will?
Yes. Symmetry, let's skip for now. Can't spell. Asymptotes, here we go. Vertical asymptotes. I am testing the limit as X approaches 3/2 from the positive. You know what? Can we do 2 first? Approach 2, because it's easier. From the positive side. Take a look at what I am doing. 2x 1/2x plus 3 and x minus 2. Okay, this is my shortcut. 2 is still 2. 2 plus is like 2.00001. So if I plug in a 2 here, that bracket is 2 times 2 plus 3. It's basically going to equal a 7. Right? It's going to be 7, but a little bit bigger than 7. 2.0001 times a minus a 2. It's going to be a really small number, slightly above 0. So what is 7 times an infinitely small number? You have to use your imagination here. It's still going to be an infinitely small number. So if I were to plug this in, I know for a fact that this is going to equal an infinitely small number, positive. So as I approach 2 from the positive side, I'm going to get a positive infinity. Let's test it. Sure. Let's try it again. Here we go. I am literally plugging in, bless you, 2 times 2.000001 plus 3, and then 2 times 2.00001 minus 2. When you multiply this out, this becomes 4.000002 plus 3. right? So it's basically the same as, right, the 7. It doesn't change much if there is an actual value it's stuck with. However, when I do the same with the value that it's basically close to, I'm getting an infinitely small. It's basically a 0, but not quite, because you can't divide by a 0. So the denominator ends up becoming a really, really, really small number. This becomes approximately 0.12345 7, really small. So knowing that this happens after you do these calculations enough times, the next time I ask you to plug in a value really close to the number already there, you will say to yourself, oh, I know where this is going. I'm not going to waste time. I know this is going to be close to a 0. But you can't get to that shortcut unless you try this manually. You won't know that why that shortcut exists or why you're allowed to do that in your head unless you do this annoying calculation. So give it a shot, okay? With that said, this is going to be essentially 1 over a really small number. It's going to be positive infinity. Limit as x approaches 2 from the negative side, so the smaller side. Once again, this is approximately a 7, like 6.999 or something. But this is going to be a negative small number. Right? It's going to be a negative small. Using memes just to maybe keep it in your heads. Okay? So if I multiply a 7-ish with a negative small number, I will get a negative small number.
It's like kind of like 1.7 by 0, but it's
exactly. If you can handle that thought, that conceptual thought, amazing. You're multiplying by 0, but it's not quite a 0. So, you know, it's something is there. Yeah, I know what you're saying. So this becomes negative infinity. So if you can do that, don't worry about the calculations. Go straight into the final answer. Save yourself time.
yeah, because I was thinking like you could just like 0 all cancels out, blah, blah, blah.
If you are okay with that idea that it's a 0 but not a 0, yes.
Is there ever a situation where like because I don't know, I can't think of a way that it would be when one is positive, the other one wouldn't be negative. You know what I mean?
Well, no, we got that last time, remember? Look, there's a negative and a negative.
Oh.
Because there's a square. It happens. Let's move on. Let's move on. We've tested the vertical limit, vertical asymptote of 2. I'm going to quickly, because I'm running out of time, test a vertical limit of 3 over 2 from the positive side. That is 1 over. This is going to be a positive over 3 over 2 minus 2. That's going to be negative 0.5.
Is it not negative 2?
Is it a negative?
Yeah.
Oh, my bad. Right, negative 3 over 2, which means if it's slightly bigger than that, on the right side, yeah, okay, so it's still going to be positive. So test it. You know what? Maybe for this number, because we have a negative value, it's best to test it, okay? So remember, this is negative 1.5 plus. So I'm going to test with the negative 1.4. Can we do that? Negative 1.49 or something? So we've got 2 times negative 1.49 plus a 3 over negative 1.49 minus a 2. Sorry, we don't have to do that. Since we plugged it in, what do we get?
2 negatives multiplying out.
So negative 2.98 plus a 3, that will be positive 0.02 multiplied by a negative 3.49. That's going to be 1 over negative 0.0698.
Can't you just think with the numbers that you only have to worry about? The signs, you don't need to worry about the numbers, right? It's like 1 over positive times negative is negative. 1 over negative is negative.
Yeah, you can do that too. Right? So for me, I see that 1 over a negative small number. This is going to slowly approach a negative big number as this continues on. If this was like negative 1.4999999, and this was negative 1.4999999, this would basically turn into that. So we've got limit of x arrow negative 3 over 2, but from the smaller side, we have 1 over 2 times, so it's going to be a bigger negative. So negative 1.5001, okay, whatever, plus a 3, and then negative 1.51 minus a 2, that equals positive negative 0.02, and this is negative 3.02. Oh, that's what you mean, my bad. So this is going to be 1 over a positive small number. So it's going to become approaching a positive infinity. All that's left from here is the intervals. So I'm going to let you soak this in just a little bit and ask some questions for the next couple of minutes. Journey?
I'm sorry,
About right here? Okay, so again, assuming that I am plugging in close to 2, so 1.99. 2 times 1.99 is almost 4. It's like 2 times 2, almost 4. Plus 3, almost 7. Yep. 7 negative. Yeah. Yeah. It's just a conceptual thing. If that makes it more clear for you, I can do that. You're right. This is 7, but smaller than 7. Okay. Now, last one. Intervals. Oh, snap. I didn't test that yet? Okay, really fast, everyone. Here we go. Horizontal asymptote. Limit as x approaches infinity. 1 over this bracket, big infinity. This bracket, a big infinity. This is going to be 1 over infinity. It's going to be close to a 0 on the positive side. Limit as x approaches negative infinity. That is becoming a negative infinity. X minus 2, so negative infinity minus 2, that's still a big negative infinity. This is also going to be a 0 from the positive side, because a negative times a negative, you know that is a positive. Whew. There we go. X-intercepts, none. Sorry, I should write horizontal asymptote, y is 0. Vertical asymptotes, negative 3 over 2 and 2. Let's test with negative 1 million, that's a negative. Negative 1 million, that's a negative, that's going to be positive. Let's do a 0. 0 plus 3, positive. 0 minus 2, that's a negative. It'll be negative. Because I know it's a positive. It won't change anything. And then positive 1 million, that's a positive. Positive 1 million, that's a positive. It's going to be plus. Here we go. Woo. If you're still copying, there it is. All right. In my 1 minute. Vertical asymptotes, negative 1.5, positive 2, negative 1.5 and 2. My y-intercept was negative 1 over 6. That's under a 1. Right there. My vertical asymptote says from right, infinity, negative infinity, infinity, negative infinity. So it's going to be here and here. For negative 3 over 2, it's going to be left side is negative, right side is positive. Left side is negative, right side is, sorry. Right side is negative, left side is positive, like that. And horizontal, it is going towards 0. And it's positive, positive. Connect the lines. It will go here, it will go here, and it will go here.
So the whole position on this side.
Yeah. Okay. There are lots of examples in the sheet. I know that was wrong. I apologize, but sorry, not sorry. See if you can complete the examples on this sheet as part of your sketching practice. The full answers to this and more will be available to you online. Have a great long weekend. If you have any questions, please come and see me. Please work hard and play hard.